Hello everybody, this is Mr. Peacock, and today we're going to be learning about solving polynomials by factoring. That's right, I'm not adding sound effects later. Ah, ghost! So scary! Almost as scary as what we're learning today. So, by factoring. So, quick note before we continue. Whenever we solve polynomials by factoring, this is a shortened version that I created for my classes and that I've also created for online because my longer version is 48 minutes long. If you would like to see it, it's called Solving Polynomials by Factoring Special Extended Edition, and I have it linked to in the description. This is the theatrical cut. So, the first way that we're going to learn to do this is by sum or difference of cubes. This method works when you have a perfect cube for both terms. Oh, I'll also add, I'm going to be a lot faster on this one than I will be in the other video, hence why it was 48 minutes long. So here's our first equation that could work. X cubed, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Then difference, same, but now it's x minus b, a minus b times a squared plus ab. Now, you should probably start recognizing some of our basic cube terms. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Also know that whenever we cube a negative, it is negative. Okay, so when using the sum or difference of cubes to find solutions, we'll also need to use the quadratic formula. And we'll be seeing this formula a lot, and I'm going to tell you right now the discriminant on all of these is going to be negative, meaning we're about to use our imaginations. What fun! Yay! I'm pausing because I'm assuming the cheers as you watch it are so loud. But we don't have time, so we're going to keep going. So here's our first example. Factor the expression using the correct formula, then solve. So first thing I look for is common factors. In this case, I have a common factor of 8. So this just becomes x cubed. And 64 becomes 8. So the cube root of x cubed is just x. The cube root of 8 is 2. So at that point, x and 2, let's start writing. Because this says minus, this is a difference of squares instead of a sum of squares, meaning x minus 2 times x squared plus 2x plus 4. Remember, it's a minus b times a squared plus ab plus b squared. All right, now that we have that, we have our first zero, that is negative 2. Now we have our second zero, but for this we have to use the quadratic equation. So a is, or the quadratic formula. A is 1, b is 2, c is 4. Please do not mix this up with the earlier AB written in blue up on top. These are different A's and B's. So, let's see. This would be a negative 2 plus or minus. Let's figure out our factors. So, let's figure out our discriminant. The square root of 2 squared. Ooh, let's use a different color. Square root of 2 squared is, so that's 4 minus 4 times 1 times 4, which is 16. So that's the square root of negative 12. So that is the square root of 1. Negative 1 is I. The square root of 4 is 2. And we cannot simplify the square root of 3. So this becomes 2i square roots of 3 all over 2 times 1, which is just 2. You'll notice all these numbers are multiples of, that's right, 2. So this becomes negative 1 plus or minus I square roots of 3. All right, let's try another one. 27x cubed plus 1, our a value, what's the cube root of 27? That's 3. X cubed is x. By the way, the reason why I know that there are no common factors is one of these is just 1. So b is, in fact, like I said, 1. So sum of squares, so the sum of cubes, so 3x plus 1 times 3x is 9x squared minus 3x times 1, which is 3x, plus 1 squared, which is 1. All right, so our 0 for 3x plus 1, remember it's negative constant over leading coefficient, negative 1/3. We could also plug this in. Now, second part, let's find our values using the quadratic formula. A, B, and C. My A value is 9, my V value is negative 3, and my C is 1. So this becomes negative of negative 3 is 3, plus or minus. Now over to the, or actually let's write this over to the side. 3 plus or minus, now over to the left where I'm going to find the discriminant. 3 squared is 9 minus 4 times 9 is 36. That becomes the square root of negative 27. Square root of negative 1 is I. Square root of 9 is 3. And we're left with the square root of 3. So 3i square roots of 3 all over 2 times 9, which is 18. All of these are multiples of 3, so it becomes 1 plus or minus I square roots of 3 all over 18 divided by 3 is 6. Okay, we're going to try another one. Factor the expression using grouping. So now we're going to use grouping. So just to remind you, it's just like when we used grouping before. We group our first two terms and our second two terms. Now, notice that this says minus, which means now that I've grouped these, the middle has to become a plus. So, greatest common factor between x cubed and 3x squared. Well, let's see. There's no coefficients that are common, but we do have x squared, meaning inside we have x plus 3. Now, greatest common factor between 4x and 12. We have no x's in common, but we do have that wonderful number of 4 times, in this case, 4 times x is now just x, and then 12 is 4 times 3, which is plus 3. Hey, look at this. Our parentheses are the same. If they're the same, then guess what? We did it right. Congratulations to us. Yay, yay, let's have a party. We don't have time. So this becomes x squared minus 4 times x plus 3. Before we do the x squared plus 4, the 0 for x plus 3 is negative 3. Now, x squared plus 4 is a difference of squares, meaning I could simplify that to be x plus 2 times x minus 2. But ultimately, I could also write it as x squared minus 4 equals 0. I'd add 4, I'd square root, and I'd get 2 and negative 2. Those would be our answers. Let's try another. So let's do it again. Yay! Hurrah! So 2x squared cubed and x squared, that would be a 2x squared times, in this case, sorry, not 2x squared, it's just x squared. Come on, Mr. Peacock. So that becomes 2x plus 1, and then plus, greatest common factor between 6x and 3 is 3 times 2x plus 1. Hey, look, the 2x plus 1 is the same. That means that we have properly factored. If it's not, it means that either you can't use grouping on this or you made a mistake. So, x squared plus 3. And all this equals 0. Now, first, the yellow part, remember, negative constant over leading coefficient. So negative 1/2. Now, x squared plus 3 equals 0. That means x squared would equal negative 3. That means x equals plus or minus the square root of negative 3, or plus or minus I square roots of 3. By the way, if you see these in the future, you don't have to necessarily show that work if you know this. So, final method for factoring and solving cubes is to find the greatest common factor, then solve. So if we did this, greatest common factor between these is x. That becomes x times x squared plus 3x minus 4 equals 0. So let's see, our factors of 4 are going to be, in this case, 1 and 4. And the negative has to be the, let's use a different color, 1. Meaning this becomes x times x minus 1 times x plus 4, meaning our zeros are 0, 1, and negative 4. Let's try this one more time. Greatest common factor is x. This becomes x times x cubed. Sorry, not x cubed. It's now x squared plus 2x plus 10. And that all equals 0. Now, one of our factors is, in fact, 0. One of our zeros is 0. But for the other one, well, let's see. If I was to factor out 10, I have 1 and 10, 2 and 5. Wait, neither of those add up to be 2, which means we have to use the quadratic formula. Yay! So, A is 1, B is 2, C is 10. So, let's see. Negative b plus or minus square root of 4 minus, in this case, 40. That means the square root of negative 36, which is 6i. All over 2 times 1, which is 2, meaning our final answer is negative 3 plus or minus, sorry, not negative 3, negative 1 plus or minus 3i. Okay, now that we've factored and solved cubic functions, we can also solve quartic functions that use the quadratic pattern. Now, when I say quadratic pattern, here's what I mean. Here's a quadratic equation, x squared minus 8x plus 12. Here is a quartic version of that. Whoa, so if we go back, x became x squared, and x squared became the squared version of x squared, or x to the 4th. But it works exactly the same. So what I would do is leading coefficient is 1 times 12, that's 12. My common factors of 12 are 1 and 12, 2 and 6, 3 and 4. And the two that add up to be 12 or add up to be 8 are 2 and 6, but those both have to be negative. So that becomes x squared minus 2 times x squared minus 6. That means my answers are going to end up being plus or minus the square root of 2 or plus or minus the square root of 6. Let's try this again. Just a sec. There we are. Sorry, I was having some technical difficulties on my end. Leading coefficient, constant, that becomes 18. Factors of 18, 1 and 18, 2 and 9, 3 and 6. In this case, the two that add up to be 11 are 2 and 9. They both have to be negative. So let's see. We are going to use the box. So I'm going to say 3x to the 4th, 6, negative 2x squared, negative 9x squared. So greatest common factor between 3x to the 4th and negative 2x squared is x squared. Negative 9x squared and 6, because it's negative, I'm going to say negative 3. 3x to the 4th and negative 9x squared, that's going to be 3x squared. And that works when I multiply these. Negative 2x squared and negative 6 is negative 2. Meaning our final answers are x squared minus 3 and 3x squared minus 2. So my common factor, my zeros for x squared minus 3 are plus or minus the square root of 3. For 3x squared minus 2, it becomes plus or minus the square root of 2/3. Finally, we have this example of a word problem. So we're going to sketch a diagram of a rectangular piece of cardboard that measures 14 by 18. By the way, this is a perfectly drawn example of that. A good fact about this cardboard is I'm going to take a piece of scissors, I'm going to cut a square on each side, and that square is going to be of x length. Now, whenever I do that, I end up getting something that looks like the top of a office supply box. The ones that you create yourself that have a top, that have a lid, it's going to end up being that. Now, the function v of x equals x cubed minus 16x squared plus 63x models the different volumes that with respect to the different values of x. So what we're going to do is we're going to factor that out to find our zeros. So first thing I can do is the greatest common factor of x times, in this case, x squared minus 16x, not squared, plus 63. Now my factors of 63, to be honest, there are a lot of them, but the first ones I would come up with are 7 and 9, and guess what? They add up to negative 16. Well, they add up to 16. Now they add up to negative 16. So that becomes x times x minus 7 times x minus 9. So my 0 for x is going to be just 0. My 0 for negative 7 is 7. And then my 0 for negative 9 is 9. So let's talk about why each of those work. The 0 would be because 0 is the value of x. In other words, how much I cut off. I can't get below 0 because 0 is the least I could cut off. In fact, it's less than I could. Now the 7 deals with the 14 because if I cut off 7 from each side, I've actually cut off a full 14 inches from each side, which means I've eliminated one of the edges. And the 9 is the same before the 18. So our final question would end up being, what would represent a reasonable domain for the volume? So if I was to do that, my lowest value would be 0. And that's not included because I have to cut something. But my highest value, would it be the 7 or the 9? Well, let's think. If I cut 9, I've already cut beyond the 14. So the highest would be 7, but I can't quite cut that whole thing or I'd cut off the side, meaning that's also a parenthesis. There we go. Now, like I said at the beginning, if you would like to see the longer version of this video because you feel like you didn't fully understand things, please click here. If not, have a good day. Feel free to subscribe if you wish, and I'll talk to you later. Bye.